recording. Okay, so again, string methods, number methods are data types that you've probably interacted with so far if you've already done some of the challenges. These are just a few existing methods that exist already on a string. So you could call dot concat, and it basically, you pass it the next string, and it will basically do a similar operation as we did yesterday, where it takes the left side of the plus sign, the right side of the plus sign, and pushes two strings together to make one string. They have a method for that it's built into a string. So you could use an underline method to do it. There's one called includes, where you can basically ask the string if it has a string inside of it, like a substring is what they call it. So if I wanted to look at a really long sentence and ask if, like, Platoon or code Platoon, if the string code Platoon was inside this really long sentence, it would give me back a true or a false, because it would go and look like it literally has the logic in place to do that for you, because it's part of it's a string method. So it knows how to look at its own value and compare it to something that you gave it, basically. And that's what these methods, a lot of them will do. And trim, if you have a really long sentence that has, this is really useful, especially when you're doing web form processing, when you're processing submitted forms over the web. You can't trust what users put in as, you kind of have to, parse what they give you, because they could have like held the space bar down in one of the fields, right, and just put like 1,000 spaces and then wrote whatever they were going to write. We don't care about all of those spaces. We want to get rid of any space before and any space at the end. We just want the literal characters that they typed that wasn't white space characters. And white space is like space, tab, the enter key. These are all like considered white space characters. Trim, if you pass it a string that has a lot of white space characters at the beginning or at the end, trim will actually just chop it off. It'll chop off all of the beginning white space and all of the end, but it won't chop off any spaces in between. It'll keep all of that intact. So that's a pretty useful method to know about, especially for some challenges. I've definitely had to use this for some challenges before. So, and here's just an example of how it might look in code. So we have double quotes, which makes, it's a string of code, right? So code is in double quotes, it's a string. So I can chain using this little dot syntax. Where's my highlighter pointer? So using this little dot syntax right here, because this is a string data type, I can chain a method to it. I could say dot concat, and I can say concatenate this argument that I'm passing in to my existing value, and it will return back a brand new built string for you. So this is another way to do concatenation. We could use the plus sign, or you can use string methods. And every data type has its own methods. So you have to keep this in mind, because you can't call concat on a number unless it has that method. So they would have to have, like, a string and a number would have to both have concat. So if you're working, you forget that you're working with a number and you think it's a string and you're trying to do a concat, then it's probably going to give you a method does not exist error or something like that. It'll give you an exception message, like the red stack trace, if you call a method that just doesn't exist on the data type. And so numbers are another data type. They have their own methods that are used for number related operations. So if you have a number, you can say to fixed. We did this one the other day. So we set, or I think we've seen it last night. We can set a decimal precision level, right? I can pass a 2 in there, and like the example is down here, except to me, this is actually weird. Why does it keep? I need to move this out of the way. Can I move that out of the way? So for me, this is weird because I have worked in a few languages, and this is, to me, this looks more like a side of, they implemented this in for some reason. Like somebody made this decision probably a long time ago in JavaScript. They said, if I have a decimal and I call to fixed and pass it a 2, it's going to give me that precision. But if you notice, like the thing it gives you back isn't a number anymore. It gives you back a string. So to fixed returns back the new value, but as a string. To me as a developer and coming from different languages, this is kind of odd behavior. I would expect, my assumption, actually when I was writing this slide, my assumption when I first wrote it was that was not a string, that was a decimal. But I totally made that assumption and I had to go look it up. So, and when I seen it, I was like, I don't like this one, but I wanted to show it just to demonstrate that this is like a case in your code where you could have, the thing keeps getting in my way, where you could have like a decimal value, call a method on it, and then you totally made an assumption. You're like, that thing should probably give me a number back again. So I'll still be working with a number, but it doesn't. It gives you a string back. So that your very next steps in your code, you might still be trying to perform number related operations. But because it comes back as a string, there are ways to convert a string, a number that's inside of a string. There are other built-ins that you can use to convert a string back into a number again. So I'm positive there's a few ways to do this, but yes, we can explore. We can look at this one specifically, like how to get it back to a number, because this 3.14 as a string is probably not what you wanted to end up with, especially if you're doing a comparison operator where you said, hey, does this thing equal 3.14 as a number, and you're using strict equals. They're not gonna be the same. Like this string version would not be, it would be a false comparison. So you always, and this goes back again to like session 1 where like data types always matter. Always try to be aware of what data type you're working with. And here, let's just hop in the docs real quick. So this takes me, they're called instance methods, right? So the way I'm using it right now in here is these quotes are basically creating an instance of a string. So the method I'm calling is an instance method. And instance, the word instance does have a special meaning, and it's really applied to object-oriented programming. And it's really hard to, I don't want to go too in depth on object-oriented programming, because that's a very depthful talk to go over. But just know, for the moment, all you have to know is the one that we're using is this one. But you'll notice that I'm not typing string.prototype.concat. This is for developers. The full name of this object wrapper basically is for developers to know where it came from if they need to do some kind of override of their own. So the MDN docs take us to a page where we can actually we could actually run JavaScript in their page right here. And you can see their version. They have a variable set for string hello, a variable set for a string 2 of world, and they take string 1, which is hello, and they do a instance method call. They're invoking the bound function to a string, and they're saying a space, but you'll notice in theirs, you can pass multiple arguments. You can pass one or more arguments that you want to concatenate at one time. So this is actually even more useful, because now you don't have to say plus a space plus the next word. So you can concatenate all of these together by just passing multiple comma separated values in here. So they passed a literal space, and then they passed the second string right here. And their expected output was hello world. So this is another way, again, to do concatenation. And when you look through these docs, again, it's like you'll get familiar with it the more you open them up and just skim through them. But it gives you everything you need to know generally right at the top. The concat method concatenates the string arguments to the calling string and returns a new string. So this is good to know, like how it behaves. This is the syntax, and this right here is not what you type. It's kind of like the format. Like this is the format of how you use it. This thing right here needs to be the data type of a string. So it literally needs to be like a string. It doesn't have to be a literal string like that. It could have been stored in a variable, but that variable needs to ultimately be a string that I call it on, right? So concat. And I can concat a space just like they did. And that's how you would use an instance method. But then they have another thing in here called static methods. You may or may not use these. You may or may not use these that often, but there are some cases where you do, especially with arrays or objects. And I think I'll show you static methods on the integer data type because I don't want to get into code points. That's code points are another thing. So, all right. Anyways, it shows you the syntax of how you would write it. So this string needs to be at like a string value, and then you can chain concat, and all of this rest of this syntax right here, all it's indicating is that you can it needs to have one parameter here or one argument that you send it. You need to send one argument, and then this like syntax they're using for developers, they're saying like it can be, you can send one or you can send more, like more, right? So they're using like n, they need to be strings. So any number of strings is what it's trying to indicate to you. Like you can send a lot of them. You can just keep you can send 100 of these things and it'll concatenate the whole thing together for you. So you can send one or a lot and then it will do concatenation. So some methods will only accept one argument, but this one is trying to let you know that its parameter listing will take in whatever you pass it as many comma separated values. So that's how you kind of read this in the docs. The return value is important. It's always check the return value when you're looking in the docs because it says it returns back a new string containing the combined text of the two strings provided. And yeah, so let me show you why this matters, I guess. So if I set name right here, I'm setting a variable name. The name is my name. And then if I do a concatenation, this is that whole thing about mutating the value and not mutating the value. If I do this concat and then I console, let me get rid of these other console.logs so they're not in the way. I'm just going to use their inline editor here. So it should let me do similar REPL things. So if I do that and I run it, I concatenated my string to name, but name didn't update, right? It didn't take that change. But that's because it's not mutating. Strings, string methods, strings are considered immutable, which means almost every string method that you're going to use is going to always return a new value. It's never going to mutate the existing string. So that's a good thing to know, because I could do this. Let me comment. Oh, I can't use short keys in here. Okay. Console.log. What if we console.log the thing that we concatenated? Because this returns a value. This statement inside the console.log returns a value. So this whole line, when JavaScript runs it, it should return back a value. And then we're going to console.log the return value. So if I run that, it is, in fact, the concatenated name. So if I needed to do this, I might need to, the updated name or something, right? So because it returns a new value, if I need to work with that new value, I need to store it. I could reassign it if I wanted to, but just know that if you ever run into a problem, right? Because name won't change, because concat does not mutate what was in there, but we are going to work with something in arrays that is going to mutate, which will be, it might make more sense too when we do that. So if I now console.log the updated name, we can see that the return value that came out of this was stored in updated name. And this is like important behavior to understand right now, because it will save you some troubles later when you're working with your variables. So we could also do reassignment. So I could say I still want it to remain as the name. I can't do that again, but I can do this again. So name. Yep. So, and hopefully that itself makes sense. And this is really coming back to like things being not being able to mutate something, a method that does not mutate, and then a method that does mutate. This one is not mutating. It is literally building a brand new value and returning that back. So you have to, if you need that value, you need to make sure you store it again, because this value will not be updated. And then, sorry, number methods. So there's another one called toString. So numbers have a method called toString. So if I was to pass, a number, or if I was to call the toString method on a number, it should convert it into a string for me. So I don't have to like do any clever tactics where I try to add the number into quotes or something like that. I can literally just call a method built on a number that says, hey, just convert yourself to a string, because you already know what your value is. Just make yourself a string. And yeah, we can look at, I actually wanted to show you static method example. So if we look at instance methods, again, we're working with, I don't like that I can't move this. So we're working with the literal value 3.1415, like pi, basically, right? Like that long decimal at the bottom. It's basically an instance of a number. That means when we call toFixed, it's calling an instance method. But there's also this thing called static methods. And a static method looks more like this. So you don't write instance methods like this, but you do kind of write static methods like this. So you physically say number.parseFloat, and then you can pass it the thing that you want it to do. You no longer need a value to work from. You just tell the built-in data type that you want to call its method. So the way that looks is, let's do this one. Number is integer. And the way this method reads, it sounds like whatever I pass this thing, it's going to tell me like yes or no or true or false because I'm basically asking a question, right? Is the thing I gave you a number? So let's look at how they use it. And they wrote a function for it. I'm going to get rid of this real quick, and we'll do it ourselves. So instance methods, again, look like this, right? So 3.14, this is technically an instance of a number. And so that means I can call an instance number or instance method like toString on it. And let me console.log that. So it turned 3.14 from a number, like it knows how to convert itself to a string, and that's an instance method. So I can also call let me store it in a variable too, just so we can keep seeing assignment operator get used. Actually, I've already used number. Here, let me number one. What's another number? 9,000. So we'll console.log. Actually, we'll do this. Number is, oh, what was it?
There it is.
Is integer.
Yes, where are you? How'd you find us?
Sorry, there's someone talking. Number is integer. So if I do this, this is, you see the like syntactic difference here. So this was calling the method literally like on, you know, what is considered the instance of the number. But this one, I didn't give it a number. I literally called JavaScript's built-in number data type. I said, can you give me, can you let me make sure this is actually correct. So we'll say 9,000 in there. And it's not going to be a number. So we'll console.log the result of this, number 2. So number 2 said true. 9,000, I asked the data type itself if this is an integer, because and this format right here is what's called static methods. So all of these are considered static methods, and you can use these to perform other kinds of operations. So like parse float, I can pass it a string and it can give me back a float, like a decimal. So let's somebody in the chat asked, so how do you return it as a number then for the previous for this case right here? If I said 2 fixed with a precision of 2, it gives me back a string, right? So if we were to do here, let me just mock up a quick example here. So we know that from the strings or the number side, right? This example, 2 fixed gives us back a string, and I'm going to say number 2 fixed 2. I want it to chop it down to 2 precision. Oh, number 1. That's my fault. So 3.14 chopped all the zeros off, but it's a string. I don't want it to be a string, so I could technically wrap this. Maybe I should do this on separate lines. So I could call the static method and say parse float and wrap it again around that. I'll break this out into separate lines. So now the quotes are gone and it's actually a number again. So that's one way you can combine that. But you could also just read, let's see, where does it say that? Number.parseFloat. This is the same as the global parse float. So there's actually just a global function in JavaScript called parse float. We actually don't even have to say number. That's literally what it's telling us is, so I don't have to do this because they've given us like a convenient function that will do it. So if I run it again, it still does it. But this is just meant to demonstrate, like, this is how you interact with static methods versus how you interact with instance methods. In instance methods, you don't worry about number.prototype. You just worry about the last bit of the last dot and what the name of the method is, because you can literally use it on that data type that way. So these are all of the things that you can ask a number to do for you. And this is everything that you can ask the data type to do for you, not the value, but the actual, just like the data type class itself. And these are static properties, so we can actually ask number for, like, these are all built in. But yeah, if you just want to see like what negative what negative infinity looks like for a computer, we can add, they do say, again, they say static properties, and just like static methods, we use them this way. So I can say number, and if I write it this exact way, I should see some negative infinity. So that's just what it looks like. That's how JavaScript interprets in negative infinity. So there's an infinity, a positive infinity, and a negative infinity. There are use cases. Everything in here exists because someone had a use case for it. I probably couldn't give you a really good example on when to use a negative infinity versus a positive infinity. Maybe if you just need like a really, really, really high or low starting point for something, or to compare to, then you could probably use one of those. But a number, it's on a number. All right. Coming back to the slides now. These are all just methods, right? So everything that we're looking at in here are pretty much instance methods. And a lot of times that's what you're going to end up using. Just the dot method name call. And methods, again, they're just functions that are bound to a given data type. So the next thing we're going to look at is arrays. So you've used numbers and strings, and now we have arrays. Arrays are a little bit more complex of a structure, because, or they're actually a structure. So they're a collection of things. If you want to store a lot of things, a lot of similar items together, and pass it around, then you're going to want something that's like an array. So here are the kinds of methods that arrays have. And you can just skim down the list here. Each one of these does some part of a job that might be useful for you. So we'll look at arrays. We'll start from the beginning of arrays and go over kind of how to interact with them. But these are some of the, and we'll come back to this slide too, because we're going to probably jump back and forth to this slide and kind of just interact with and see what these do. Push, it lets us add more items into our collection or our array. Pop, it will remove the element from the end of the array, and it should pass it back too. So not only does it remove it from the array, but it hands it back to you like a return value. Shift removes the first element of the array, and unshift adds elements to the beginning of the array. Slice, we can slice from starting and ending points. So we can, if we wanted to chop off certain parts, we can basically cut off any portion of the array and only keep the parts that we want if we know what those are. Splice changes the contents of the array by removing or replacing existing elements. So we can splice in other arrays into an array. Or splice out portions of the array. Index of, we can ask for, well, we haven't really talked about indices or index yet, but we'll probably touch on that first when we start going over arrays. Join, join will let you, join is really handy. You can, once you learn how to use it and how it works, you'll probably use it all the time. I use it every chance I get. So you can take every item, every value that's stored in your collection, and join it together into one single string. So if you have a bunch of values and you want a string where it's like people's names, right? If it's an array of names, you can, and you want to generate a string that's just everybody's name but separated with commas, you can join and pass it the comma, and it will join everything in your array and create a string out of it. It's really useful. For each, we can actually ask, so this is a built-in method, we can actually ask the array to perform a loop on itself. We have to pass it a function of what we want it to do, kind of like a loop block. If we were to go back to loops, there's like the different style of loops, right? So you have while loop or a for loop, and you had a block of code inside your loop for the thing that you want to perform repeatedly. So for each takes a function and that function block it's going to repeat for however many items are in your array. So it's really handy. And map, there's no description, but map kind of does a similar thing as for each does, except that it's I'm going to be careful with my words here. We can pass a function to, and map will iterate over whatever the collection is. So if it's an array, it's going to iterate over each item of the collection, and it will pass in each item one at a time and perform the logic that you define in the function. It's just like for each, and you can also pass it a second argument, which is indexes. But we'll go over these two. Don't worry about these two right now. These are getting a little bit ahead, and they are confusing for new folks to use in the beginning. It's actually better for you to start with while loops and for loops before you start jumping into map and for each. But they are good to know about once you've practiced with the basic loops first, like the while and the for. So yeah, we will move over to a REPL, I think. And I'm going to, we'll look at arrays first. Just what the structure looks like, what you can put inside of them, and how to loop over an array to do something. So maybe the easiest array that comes to mind is an array of students, right? So we can just throw a few names in here. Just going down the list, not picking on anybody specific. We'll put one more. Okay, all first names. It's just an array of all first names. Now, arrays, the way you can think about arrays, if we were to count, so thinking as a human, not a computer for a moment, if I was to tell any human to count this that knows how to count, they would count this as Daryl would be 1, Lucas would be 2, Lisa would be 3, and so on, right? We would just go down the list, 1, 2, 3, 4, 5, 6. Arrays on a computer, this is tied to specific languages. So JavaScript counts arrays from zero-based indexing. So it doesn't count starting from 1, it counts starting from 0. Do I remember all of these, or do I have a cheat sheet? I don't have, I'm not talking from any cheat sheet right now. So this is all memorized. I'm kind of just winging everything I know to you, but trying to break it down in a way that's more understandable for a beginner. Sorry, someone was asking a question in the chat. So arrays are zero-based index. So I'm going to put these on separate lines just so I can emphasize. It doesn't matter if it's on one line or multiple lines here, as long as the syntax is correct. So I'm going to put these all on separate lines. Now, normally a human would say 1 and 2 and 3, but that's let's check. Let's check how JavaScript responds to that. So I'm going to console.log students, but I'm going to use something called bracket notation. And I'm going to pass it 1. And I want to see what it gives me back. I can access these items by a very specific number value. I can say, give me the first index, but like I said, computers don't count from 1. So I technically should get, oh no, give it a second. My REPL session does this I think it goes to sleep or something. It has to wake up. You can do it. Do we count from 0 in arrays? Yeah. Yeah. So JavaScript arrays, right? JavaScript arrays are 0-based index. But I'm showing you what new to programming folks do. Usually they think like a human still, right? They think like I count from 1, and they treat the first item in the array like the first item in the array, but it's technically the 0th item in the array. Why is this not running? Let me refresh it. Oh gosh, hopefully it saved my work. I should have copied that. Probably didn't save it. Oh, it did. Sweet. All right. So let's run it. And it says Lucas, right? Lucas is my first item. No, that's not right. Lucas is the second item, but again, this really should be this, if that makes sense. So when you talk to arrays, they will always start from 0. If you ever are iterating over a string or some kind of array or collection of things, because you can index strings as well. So if I say 0, give me the 0 index, that should be the first item. So Daryl is the first, and because it has indexing, it knows the order of this array exactly as it is, because when you loop over an array, it's going to start from 0 every single time, and it's going to, at the first iteration will have Daryl, the second iteration will have Lucas, and then so on and so on. It'll just keep going down this list. So if I wanted to, if I want to interact with this array, I'm not gonna want to do like, I don't want to hard code like the numbers in. Like everything I want to perform, I don't want to have to remember how many items what happens if I go over 5, right? What happens if I try to access 6? Because what happens if I try to do that? It says undefined, which, all right, what's 5? It's Michael. So if I accidentally go 1 too far, I'm gonna have a student named undefined. That's not gonna be good. It's gonna maybe put something in my database that I don't want, or write it to a file, and I don't want undefined written to the file. I only want just the names I have. So using like loops, I guess this is a good time to actually use some looping mechanisms. So which one do we want to do? Let's jump back real quick to the first session, because I think we just barely touched on a few different ones, right? So in the first session, we were talking about these, right? While, and then we give it some condition. And this is kind of an example of how you would do it. And then there's also for, the classic C-style for loop. So we can do this one. I kind of like these ones. A lot of languages use it. Java, PHP, all these different languages use it. Yeah. If your REPL freezes up, definitely do like highlight everything and copy it and then refresh it. I got lucky, I think. It saved what I had in there. So coming back to, okay, no, that's not the right screen. Coming back here, we're gonna do this for loop that's like this, that style. So I'm gonna say let I, this is gonna hold our index. So it's basically gonna hold our starting point, and then it's gonna keep incrementing it until it can't, until it has to stop, basically. All right, so let me jump back to the slide. That way you can see me convert this line by line. Oops, wrong one. Okay, so I need my initialized variable counter. I need my run condition. and I need my increment or decrement count. Probably just call this my incrementer or decrementer. And we're going to increment because deciding whether you need to increment or decrement is entirely based off of what your run condition is checking for. So in this example, it's saying, is I less than 100? But that's not what we're going to do. We're going to check. Actually, I'm going to have to show you where this comes from. So I'm going to say if I is less than the array dot length. And before I continue on, let me show you where that comes from, because it's not in my slide. It's not a method, right? It's not a method actually. So it's, let's go to arrays. And if we come down here, there's a bunch of examples of how to use all of the array things. But if we keep scrolling, eventually we'll hit this section where it says constructor, static properties, static methods, and then there's this one called instance properties. And just like instance methods, we don't say array.prototype because our array right here is already an instance of an array. So we can just say whatever the current value array is dot length. We can ask it what its length is. And before I continue on, let me just do that, right? Let's ask the array, students, what is the length of this thing? And it says 6. So 1, 2, 3, 4, 5, 6. There's 6 items, but the indices goes from 0 to 5, which makes, if you count from 0 to 5 is 6 items. So my condition in my for loop, this second, I don't want to say argument, but so the first like clause that we need for this for loop to run is our counter, the initialize counter. Then this is the run condition. This is the condition that will make the loop stop. So if I say what only keep looping, here, let me write it here. I is less than students.length means keep looping while I is lower than the length of the array. If that makes sense. So I'm saying this single run condition is basically saying, like, I want to run this block until I is at the same count level as the length. So when I reaches 6, stop looping. So I plus plus, and this is an incrementer. It's basically going to take I and say, take the previous what I previously was and add a 1 to it. It's like a shorthand way to increment by 1 each time. So if I loop now, I have my loop set up so that it's going to loop hopefully 6 times the way I have it written. And then I want to just print out something to the screen, right? We'll just say name, and then we'll pass it. We'll pass it the index position, which is I. So at any point in the loop, when we iterate, right? So when this loop begins, it's going to be on the first iteration. And mind you, this is going to happen extremely fast. So it's going to look like it's going to look like everything ran at one time. But this is happening in steps. It's going to like start from 0 for the first iteration. So let me put it here. Iteration 1, I will equal 0. And then iteration 2, I will equal 1. And if you keep that in mind when I write this next line, it might make sense. So Remember how before I said, I don't want to have to access the item specifically, because this would loop 6 times if I put a 0 here, and it would say Daryl every single time. Like, cause I literally put the 0 hard coded in there. But if I say, why can't, like, I starts from 0 and then it, you know, increases. Did I mistype this? What did I do? I'm not sure why. I don't think I have to have a semicolon at the end of that. Do I have to use semicolons in the REPL? I don't think I do. Maybe that's just an editor. We'll find out. If it doesn't run, we'll find out. Sorry.
Chris?
Yep.
Quick question for you.
Sure.
Why would you not set the run counter to less than or equal to students.length?
Yeah, we can we can totally experiment with these, like, different values that were the condition value, the incrementer, and everything. So here, let me make sure this will run like it is. So yeah, it runs 6 times, says Daryl 6 times. We can, because we've kind of set this variable for us to start from 0, and then every time we reach this point right here, what the loop is going to do is it's going to come back up to the top, and it's going to reevaluate this condition again. So this is going to increment I by 1 when it comes back to the top again, and it's going to say, hey, I, are you still less than the length of the students array? And if you are, we're going to go again. We're going to do this again and again until I is no longer less than the length of the students. But if we put an equal sign, we say we're going to start from 0, and if I is less than or equal, so I can be 6 now. If I is 6, it will match the length of the students. It will run this block of code again. So if we run it now, you'll notice that we get, there's 3, and now we have 1 extra run. So it actually ran 7 times. And if I'll emphasize this, I'll emphasize it one more time. I'm gonna put it back how it was. We're gonna put this I here just to make sure it'll work. So now I'm using this index value that we're incrementing. So if I run it now I'm printing out line by line every single person that's in this array. But what happens if I put that equal sign back in there? Now I have a name at the end where it's saying undefined, because if you think about this, right? Here, let me copy, I guess. We're kind of like going through these. If we write this all, if we write this all the way out, which is probably a beneficial thing to do, so you can just make sense of what's happening here. Right? So if I'm telling it on the very first iteration, we're always comparing this condition, and students.length above is equal to 6. So that means as long as this condition is met, we're going to start from 0, and I is going to be 0, right? And then it's going to be, so if we go down the list here, so that first one is 1, 2, 3, 4, 5, 6, right? But we said, I still want to run, if I is currently at 6, I still want to run it. So we do a 7th iteration on an array of 6, which kind of ends up giving us, we hit the undefined mark, right? Like we went 1 over where we were meant to go.
I'm tracking with you now. It made a lot more sense when you wrote it out like that.
Yeah. I had to write, this is what I had to do. Loops are hard to explain if you don't do this, because not everybody thinks about it in terms of iteration count, right? Like I'm trying to represent every iteration that's about to happen separately, one right after the other, because otherwise you don't, there's one more way that I can also represent it too, is like a console.log iteration out, our iteration count maybe, and I could say I, and we could see what we're currently on. So they print on separate lines, right? So our I is at 0, it's Daryl. I is at 1, it's Lucas. I is at 2, it's Lisa. And then we finally get down to I is 6. But if you look, but if you look here, we have no 6th index item, and that makes it undefined basically. So that's why a lot of times you'll see, like if I did this, I would probably have to, if I wanted to use that equal sign, I'd probably have to subtract 1 from the length to make that work. So now I don't hit the undefined case, because I said length was 6, but now I'm subtracting it down to 5 to make sure that my my I can be equal to, my I can be equal to that very last item, but not after that. But yeah, so sorry, I just hit there's like a button on the side of my mouse. And if I press it, it goes back on the browser, is what it's bound to. Didn't mean to press that. Anyways, if that makes sense, like if this becomes 5, we're saying that if 5 is less than or equal to the length minus 1, so 6 minus 1, if 5 is equal to 5, I want to run this block still. But a lot of times you won't see it written this way. You'll see it written less than in most cases. Especially if you're working with indexing, this is pretty much how you'll see it written, is like that. So this is how you loop over a collection that has indices basically. So I could actually loop over every character of Michael even, right? If we just want to touch on loops, if we just want to touch on looping over other things besides an array. So I could also say, I should be able to say the same thing. And now it's going to be, because we're going one by one over a string, each item is now going to be 1 character at a time. So if I do that, oh, did I not? I said students, whoops. So now I have to change my references. So now if I do it, M is the 0 index, right? So M is 0, I is 1. And then so on and so forth. It's just like an array, right? Like I can't break this across multiple lines, but you can see how like the first item in the array is 0. The first character in the string is technically the 0 index. So that you can iterate over individual characters. You can iterate over individual items of everything inside of an array. Hopefully that makes sense. And so that's iteration. Do y'all want me to change this into do you want to see a while loop as well? Like looping over an array with a while loop? Basically converting this for into a while loop?
Yes.
Okay. Yeah, we can do that too. We can do all 3 types of loops for arrays. So I'm going to comment this thing out, just so I'm not running a lot of console.logs in here. And I'll leave name because we'll use that again. So let me open the slide again, just so we can refer back to session 1 under the iteration slide. So we just did this one, right? Let me make that bigger. We just did the 4 over here, and I'm going to convert this one into the while version. And then next we'll do, we can't do this one because this is for object types, but we can do for of next if y'all want to do and see the same thing. 3 ways to do the same thing. So the first thing with the while loop is we need that same counter. We need that same like I. I mean, we don't have to call it. We can call it C if we want to. It doesn't matter as long as we as long as we're careful here. So inside of these parentheses for a while loop, you have to put your condition. Like the condition, if it evaluates to true, we keep running the block, but the moment it's false, it will stop running this loop. So I'm going to put console.log down here and put like loop ended, just so we can see that we are staying inside of this block of code. And then finally, when it ends, we'll hit loop ended. And so the condition that has to happen in here has to equate to like a true or a false. So we need to say something similar as what we said kind of like up here, where we said, all right, my condition using comparison operators, I less than students.length. So as long as I stays less than students.length, it will run the things in here. And we can actually do that same iteration count, just so you can see. But right now, I'm not sure how Replic's going to respond if I do this, but yeah, this will be interesting. Maybe it will force stop it. This is an infinite loop right now. Like if you look at this code, I've basically said as long as you remain less than students.length, run this block of code. But I did nothing currently. This is where you have to be careful with while loops. You can also do this in for loops, but especially while loops, it happens a lot. So I wrote nothing to increment that 0. So I'm going to be in this loop for the end of time, unless I stop it myself. So if I run it, we'll see. We won't see. I said you probably caught that. C. So I changed the name. That's also wrong. Fix my references. I'm so used to writing I. So I just had to make sure that these were correct references. I was using I for some reason. So if I run it, right, it's just going to go. It's going to keep going. It's literally stuck in this loop saying that 0 is not changing. And you're totally going to write an infinite loop, and it could lock up your computer. It really depends on the performance. It doesn't seem the REPL is breaking, but on my computer I can hit Control C. It might be Command C if you're on a Mac, to basically like stop, like kill the program, make it stop. So it has stopped now. So I need to make sure that doesn't happen, because that infinite loop we basically have to kill the program to get out of it. It will be stuck there forever. So C, I can do this the long way. I can say C is equal to C, which would be 0, right? It would be 0 currently on the first iteration. So C is equal to the current value of C, which is 0. This is reassignment, plus 1. So basically I'm saying I want to set C equal to 0 plus 1, which is going to be 1 every time. And then next time it comes around on the second iteration, this will be 1. So that will equate to 2. So I'm just incrementing by 1 every time. So I can write it like this, which is a long way to write this. This line is this line. They are the same line. And I could also, that's funny, it came out C++. C++ is a coding language as well. But basically they increment by 1. So if I run it this way, we see that now we never reached loop ended before because we were stuck in there forever. But now that we ran 6 times, or 0 through 5 times the indices, we hit the loop ended at the very last line. But so now we can do the same thing we did above, where we do console.log and we can do name and what was it, students, and we pass it the C now because C is our index. It keeps track of what index we're on. So it will run here. Let's run it this way first. So again, we have all of the names printing out and all of the iteration counts, but you can play with these. You can play with these, the placement of these. The placement actually affects what's going to happen. So what happens if I put this at the top instead? How does that impact what's going to happen? Now we don't print, now we don't console.log Daryl out anymore. It basically, the very first line of our loop is skipping him because it started at 0, but immediately turned it to a 1. So we technically skipped over him.
I'm hurt.
Yeah. So if I put it back at the bottom, what happens if we say, all right, increment by 2 every time? So now we're going to skip every other student. So we start at Daryl at 0, and you'll see that we're skipping by 2s now. So if you want to skip odd numbers, or odd index numbers, you can. We can just increment by 2 every time, or I can increment by 3 every time. So our list gets smaller, and now we've done 0 and 3. Yeah, so that's a while loop. They're basically, let me put that back. So now we're looping with a while loop, and they basically just do the same thing. They're just 2 ways to write the same thing, but let's comment this one out and do the, what was it, for of? Yep, for of. I always get these 2 confused. I always have to try to remember if of is for the array or if of was for an object type. But we can use for of, and if you look at the format here, if we have an array, whoops, let me make this bigger. I always forget about that. If we have an array, there's only 3 items. We don't have to specify. We don't have to specify each item of the index of the array. It knows how to loop over those. So let's make sure that that actually happens. So we'll do for let, and because our array is called students, I'm going to create, this is a temporary variable. It's going to store every item inside this. And I say for students of students, and we can console.log. Here, I'll do it in all lowercase. Student. So I'm gonna loop over every single student, and then let's see what happens with that. So again, we didn't even need index positions now, because this style of a loop knows how many times it's built. The keyword of is figuring out how many times it needs to iterate, and it's grabbing the values out for you, and it's storing basically each time through this loop, right? It's basically saying, all right, student on the first iteration is going to be equal to that one. So let me write it out properly again. Iteration 1, right? So you can think of it like this, right? So it knows for you. So iteration 2, 3, and 4, right? It's basically reassigning student every single point in this loop so that you can access each item individually and run whatever code you need to run. So I could console.log, because student is a string, right? This is an array of strings. That means student at every single point is a string data type. I can do concat s. I can pluralize everybody's names for some reason, right? So now Daryl's, Lucas, it just basically added an s to everybody's names, right? So I can treat student as student is holding each one of these values at each iteration, at each point in time for each iteration, right? Like it's holding, but these don't have to be strings every time. Like there could be numbers or something in here too. So if you're looping, you want to make sure you're looping over all the same type. If you're going to use something like a concat method, you have to make sure all of those are string types in there. That's just something to note because we did cover instance methods, right? Yeah, that's pretty much it for like the looping portion of arrays. So we can actually do, let's stop right there. And you guys have any questions on anything we talked about so far? We can go over some more array methods as well. Or would you prefer to, because we're already at what, an hour and 16 minutes since we started. Usually I'm done talking by now, and usually at this point I would have you go work on a few challenges, and then we can come back with questions again and review some kind of a challenge. So I'll, if y'all would prefer to do that, we can do that. Can we work for a bit? Yep. So yeah, if everyone's kind of on wanting to go try some of this stuff out themselves, we can do that. I can let y'all go for like 45 minutes and go work on some challenges and try like arrays, and I'll still be hanging around, and then we'll meet back up, and we can review a challenge basically. And if you guys have a preference, if y'all have a preference for a particular challenge, try not to jump too far ahead in the challenges, just for the sake of anyone who's still trying to keep up. We can maybe pick from the next of the list, right? So I think we did total change due last time and converting hours to minutes, but we can pick maybe another one and go over it if you prefer, or we can just continue on with array methods. But yeah, I think that's what we'll do. I think I'm gonna release y'all to go work on challenges right now, and you can hang out in the Zoom call. The Zoom call is gonna stay up, and I'm gonna stop recording for this time while y'all are working on everything. I'll still be in Slack. I'll be jumping between the Slack chat and the Zoom chat again if y'all have questions or you're stuck, and then we'll come back at let's see, it'll be 6 for me, so that's 8 p.m. Is that okay? Is everyone good for 8?
Hey, Chris, is there any way that you can tell us which ones are arrays, and maybe we can work on 2 or 3 challenges? When we come back, we'll work on the same thing?
I can't tell you off the top of my head which are arrays, but they might be actually, they're actually prefixed. So yeah, they are. Okay. So inside, if you're using this sheet, they actually give you a hint at what they're covering. So this one is like conditionals, control flow. This is control flow and data types. So, and then this one is like using loops. So down, like much farther down, they're arrays and loops. Like to solve these challenges, you probably need to use an array, or you are using arrays, and you're going to need to loop over them to solve it, most likely. So
should we do like maybe 27, 28, 29 to work on those and then come back so we're all on the same page? Or?
Yeah. I'm not making assumptions on, because some folks have to leave early or some people aren't making it. So if you're still wanting to practice up here, it's fine. And if you're going to rewatch this video later, once we get it up, then yeah, but we can totally go over any one of these. If y'all want to work on specifically the arrays and the loops for today, and you want to just jump down the list here, and because this is what we're talking about today, then yeah, that's, try to shoot for these, and then maybe we'll cover one of these and talk about how to maybe solve high score, or I don't know, whichever one y'all want to cover. I haven't specifically done some of these actually. So some of these might be new for me to solve, so it'll be interesting. I mean, it's going to be similar to any of the other challenges I've ever done probably, but the context will be different. But yeah, go ahead and start working on that, and be back in maybe, let's shoot for 8 Central Time, so 40 minutes from now, and then we can review and everything. If everyone's good with that, and I'll be around. So if you have questions and stuff, I'll I'll get to questions in Slack, but I'm going to stop recording for the moment. Oh no, I didn't. I forgot to start recording that when we came back. Well, it's recording now. So array. So you want to see an array challenge? I mean, we can do high score. Let's look at it. So, yep, high score says write a method that takes in an integer array of student test scores and returns only the highest score. Okay, so this is the function call. This is like we can use this as our test case when we test it ourselves, because we know that we are expecting to get back a 92. So each one of these items in here in this array is supposed to represent individual test scores. So we basically need to like loop over each one of these items and then find the one that is the highest out of all of them. So we have to loop and then remember which one was the highest so that we can return it when we are finished looping, right? And that's me just thinking out loud about how I need to perform in like human words, how I need to perform this. I'm just trying to make sense of the challenge. So yeah, let me copy this over. Oh, not that much, just that. All right, so let's put that in there. And I do that every single time. Fork it. If y'all have any questions, you can feel free to stop me before I get too far here. All right. So I'm using a multi-line comment now. So we open it like that, and then we close it with the opposite symbols, right? So /* begins the multi-line comment. And then the moment I put */ it ends the comment. Because if I didn't put that, now I commented everything. I commented the entire file out. So yeah, that ends it. All right. Write a method that takes in an integer array of student test scores and returns only the highest score. So student scores, the thing that gets passed here, first thing to understand when you're like writing your functions, your own functions, or working with a function that's provided you but has no body of the function, student scores, it already told us it's an integer array. We can expect that it's an array containing number, like number types. So those are our types: array containing many number data types, right? So array of number. So student scores is an array of, I mean, it doesn't say it could be empty. So the challenge doesn't specify that we need to handle what happens if we pass an empty array. So let's just say that it could be, I guess we'll set our own terms, one or more numbers, I guess, right? Student scores is an array of number data types. So we'll kind of just set our own terms since none were set. This is what we'll try to write it for, right? One or more numbers. And which way do y'all want me to loop? I can use any of the way. Oh yes, I can increase the size. Let me do that. Is that better? It's pretty big, but I should really like stream this on a different monitor that I can put the resolution down a little bit lower so the image is blown up without me having to zoom. Bingo. All right. So do y'all have a preference for which way I loop? Do you want me to use a while loop, the regular for loop that has like the three different
loop.
The for loop, the one that looks like this? That one?
Yes.
Okay. All right, so we can loop like that, and that's the one I'll go with. But first, I'm gonna think out the rest of these steps that I want to do prior to writing any code, because this is always a good practice. It takes a little bit more time, but it's definitely good practice for when you're new. So again, rereading this, it says write a method, write a function that takes in an integer array of student test scores and returns only the highest scores. So we know that we're going to need to remember what the highest number was, and we can't do it inside of the loop, because if you set a variable inside of a loop, that variable it's going to get reset. Like you're going to overwrite the value or reassign the value, most likely is what's going to happen. So we need to remember a number, but out before the loop ever happens, right? So we need to like, I almost started writing code. So we need to, step one, maybe we need to like initialize or basically just set as a variable where maybe we'll initialize a variable to 0 for the moment. We'll see how this turns out, but we'll initialize a variable to 0 to hold our high score, because we need to remember it. And then step 2, we will start to loop over each item in our test scores, student scores array. And as we do that, we're going to have to decide whether we need to update our variable that we're storing. We're going to have to use a condition, right? Like we're going to have to compare we're going to basically have to compare our current value to whatever value we have stored, if that makes sense. So we basically need to like check our current value in the loop is on against our high score that we want, against our high score variable, right? Like we're looping over each item of the array, but we also have a high score that we're trying to that we remembered. And every time this loop goes through, we need to compare against our current item against our previous value. And then, so we can say, this kind of has two sides to it, because this is a condition, right? So we'll say that 3A is the truthy side. So when our current value is greater than our high score variable, sorry if this is a lot, I'm just thinking out my plan of attack right now, kind of step by step. And so the truthy side of this condition that I'm about to write, when our current value is greater than our stored high score variable, that current value needs to become the new high score variable. That's like our new highest number that we've encountered. It was higher than the previous value, so therefore we need to make it the new highest, right? So make it the new highest. All right, that's getting to be a long line. So 3B, we'll say it's the falsy side of the condition. When it's the falsy side, our current value doesn't need to replace the high score variable. It actually doesn't need to do anything. We don't want to do anything. So I'm going to say do nothing. And once this loop finishes, if this truthy value is written the correct way, our high score variable should have the last highest number as its value. So we need to return it at the end. So this is more steps than we had to write last time, but it's fine. So I know I'm working with an array of all number types. So if I need to do any kind of number comparisons, like I know that my operators are going to work the right way when I'm only working with numbers. I don't have to like make assumptions that one might be a string and one might be an integer, and the comparison could end up wrong. These are all numbers, so they're going to compare. My assumptions should be correct. So the first thing I need to do is say initialize a variable to hold 0 as our initial, it's going to be basically our initial high score, right? So I need to be able to reassign. I can't use const for my, I don't want to call this high score because, well, I can say high score, but it's very close in terms of the function name. So maybe we'll call it highest score. It's probably a better name, but I can't use a constant because we can't loop and then reassign a constant. So this has to be, we have to use let so we can do a reassignment inside of our loop, because constant will not let us change a value once it's set. Just revisiting old topics now. So session 1. So let highest score equals 0. That's step 1. Step 2, we'll start looping over each item. So the same way I wrote the loop last time for the arrays, it almost looks like this every time that you need to loop over like an array that you need to use indexing with. So I'm setting I, it's going to hold our index position reference. So let I is 0. It's going to start from 0, while I is less than student scores is an array type. I can call dot length on an array type. We talked about that one too. So, and then I++. So this format right here is almost, every time you write this for loop, it's going to look, it's most likely going to look like this almost every time, except you're going to be swapping out whatever your array is going to be here. So this becomes like, you're going to write this so much that it's going to be like second nature to write it. You're going to just, I remember exactly how to write this. It doesn't always have to be this way. Like if I wanted to say, if I change this operator to greater, right? Then I have to change like this to be greater. And then I have to decrement instead of increment. Just know that. This isn't always this way, but it's really like, almost every time I interact with a for loop, it's always structured this way because you're almost always using it to iterate over like an array. Okay, so inside this loop, we need to, we're currently looping as many times as there are student scores in the array, right? So this, right now, that's not helpful. We need to access each of the current, like the current item we're on, right? So hopefully this one will make sense. So if I put I right here, we can call this thing we can call this our current item, or we could call it current score, which reads better because that tells us, it's the current score that we're currently on, no matter what point in the iteration of this loop that we're in. So we're going to loop however big this array is. So it looks like 1, 2, 3, 4, 5. There's 5 items. Dot length will be 5. Current score, the first iteration, would hold 89. So if we look at the next step, we have to check current score. Let's pretend that this is our array, right? I think this might be easier to visualize this way. We'll say students scores. This is our we're gonna keep this array in mind as I go through this as an example, because it'll make it more clear. So the first iteration, I'll do this thing again because it seemed to be helpful last time. On our first iteration, current score is gonna be 89. So this line on the first iteration will be 89. Instead of the semicolon. No, 4 isn't really, 4 is a keyword. It's not really, it looks like a function call, but this syntax comes from a lower level C language. So I know it looks weird to separate semicolons as like, it almost looks like semicolons are like the arguments. Sorry, we're sidetracking a little bit, but yeah, this is kind of like the way that you write this style of a for loop. But it's not like, you don't treat it like it's a function call, but it does look this way each time. So we need to do our condition, check our current value. The loop is on against the high score. So up here is our variable set. It's not going to change until we change it, but we only want to change it when current score is greater than our highest score. So anytime this happens, anytime this statement is true, we want to change highest score to what current score is right now. So if I say if, this is where we can combine a for loop and a condition and conditionally do things while this loop is occurring. So now we're combining multiple concepts that we've been learning. So I could put an else here, but I'll see why that doesn't matter in a minute. So current score is gonna be 89, right? Highest score starts off as 0. It's gonna stay 0 the whole time because we haven't changed anything. But this is our truthy side. So when our current value is greater than our high score variable, make it the new highest. And this variable is representing our new highest. So I want to say, I want to do reassignment, right? And this is why I couldn't use const before, because const wouldn't let this happen. High score or highest score is now going to be equal to the current score. So whatever current score currently has, now highest score is going to be that number, right? So because 89 was greater than 0, now the highest score is going to be 89. And you can see that the second iteration is going to be 76, right? So what's going to happen if I write this line, highest score holds 89, and on second iteration of this loop, when it comes back through again, this will be 79. So you can look at this line again, right? Current score, this line right here would equate, if current score is 79 and highest score is 89, that's a false, which means the else statement would run. So we could do something in here if we needed to, but I don't need to do anything if the current score is not beating the highest score, right? So I can technically just leave the else statement off. I only want to do something. I only want to change highest score when the current score has beaten the highest score. So at the moment, so do nothing for falsy. I took it back out. High score variable should have the last highest number, and I want to return it. So I need, so this is a good thing too. I'm going to mess this up on purpose just to show something that a lot of students do this and don't realize it. I'm going to return highest score, and we need to actually write something so we can, if I run this right now, it's not going to do anything, right? I get nothing because I physically need to like copy one of these cases to test with. So I'm expecting a 92 to come out. And when I run this call to my own function, I expect, with this data set that I'm passing, I expect that 92 to come out. So we're going to do that. I'm going to call that. I'm going to explicitly console.log too, because I don't want to rely on the console. So we'll call it our result, and we'll console.log that result. Because our function returns a value, it will return the result of this value into result variable. So let's run that. And it says 89, which was our first one. And if you notice what I did is I returned while I was inside the loop. Like, so this closing brace right here, or this opening brace right here is, I'm technically still inside the loop at the moment, right? I am still, this is outside, this is outside the loop. And this line is still inside the loop block. So the problem here is that inside of a function, when you hit a return statement, when you call a function and that function hits a return statement, everything stops. You exit the function. Nothing else will run. So on our first iteration, we were at 89. We still ran, we ran this code, right? And highest score did get set to the highest score of 89, but we returned it on the first iteration. So the loop didn't even finish iterations. It did iteration 1. And because we ran into a return statement, it stopped the loop. It basically broke us out of the loop and exited the function immediately. So you have to be careful where you put a return statement, because it will exit your function with that value. So we have to move this thing outside of the function so that the whole every single iteration of our loop can take place. Like, it will go from the start to the finish of our array and test every single value. And if we do that, uh-oh. Did it really fall asleep in that, like, less than 1 minute? Let me copy this just in case. Maybe it doesn't like how many times I run this. All right, I copied it. So I'm going to refresh my screen. Looks like our code is still there. And I have it. Okay, it saved it. All right, let me run it again. And now it says 92, which is the result we wanted, right? Or at least that's what the example told us it wanted. But if it's also good to manually check this, right? Like, based on the problem they gave us, it says it takes an integer array, which is this, of student test scores, and it returns only the highest score. So if we, like, as a human, go through this one by one, 89, okay, that's currently the highest. 76, it doesn't beat 89. So 89 is still the highest. This is basically what our loop is doing. 56 doesn't beat 89. So 92 beats 89. So 92 is the new highest. And then 66 doesn't beat 92. So after looking at each item of this array, 92 won. 92 is the highest. And then basically, if you read this as you would do left to right, your brain does it automatically, right? Like, if I tell you to, hey, here's a list of numbers, give me the highest number, what do you do? And if you think about what you do in broken down steps, you can kind of imitate code in a very similar way. So I'm reading left to right, step by step. I could do this a lot faster because I know how I've been alive long enough and had schooling and stuff that helped me understand how to do this in a step-by-step process, right? So 67 is our current highest because it's the only one we've run so far. 97 beats 67, and 96 doesn't beat it, 92 doesn't beat 97, 90 doesn't beat 97. So 97, and the thing to keep in mind is we were returning, right? We were returning after 67 when my return statement was inside the loop. So it was never running these. It would exit with 67. So if you want to find the highest number inside of an array, you have to go over every single value to find it, especially if it's not sorted. This is not a sorted list because, 90 is over on the right, 92 is before it. So yeah, it's not sorted from left to right, lowest to highest, or highest to lowest. It's kind of just like, these are things to keep in mind, because if you think about that, if this was a lowest to highest list already for me, I don't have to iterate over the whole thing. If it's already sorted lowest to highest, my highest number is on the far right. I could pop that number off. I could literally call, what we just learned. I could literally say, here's my array. Whoops. Here's my array, pop. And it would pop off the last number if it was in, ascending order. So lowest to highest. But those are things to keep in mind. And usually a problem statement like this would tell you, it would say an already sorted integer array. If it said that, that gives me an indication of what actions, what I know beforehand. If it's already sorted, I know that I can actually skip all of the iteration because it's already sorted. All right. Let me read a few of these questions in the chat real quick. I need to catch up. Compared to high school, yeah. I read that. So you're basically running all the numbers against each other and tracking it with the highest score variable. Yeah, that's exactly what I'm doing. So yeah, I'm basically initializing it to 0 because at the start, I haven't looped over the first number yet. I don't know where to start. So I'm just making that decision. I'm saying 0. Every test scores, like 1, if they had a test score of 1, it would beat 0. So maybe these were all failing students, right? You don't know. It could be, you don't know what these test scores could be, but if you know it's a range between like 0 and 100, 0 is your lowest. So we could set 0 as our lowest test score because anybody else will beat the lowest. So I kind of like automatically went to 0 because these were test scores, but that might not always be the case. You could be working with numbers that aren't representing something that's a range of 0 to 100. Maybe you have negative numbers, right? Maybe you start from like negative infinity yeah, you might have cases where your number line is a lot larger. So you start from negative, maybe you have negative thousands in there. So you have to know what your min and max values are and the array that you're testing. So these are all considerations when you're trying to problem solve. But this is how you think about it. Like, this is how I think about it. I go through this stuff in steps. I'm like, all right, will this work for every iteration of the step, right? Like, I can always look outside this loop and compare myself to this initialized variable and then just reassign that when I need to. But yeah, hopefully this helps you understand like iterating. So we're doing a lot of things in here, right? Like this is me initialize, and now I have a lot of comments. It's starting to get cluttered. So initialize the variable. I didn't have to do this line. I could have just literally used this line in place of everywhere else. I could have just done that. But just for convenience and for, I guess, readability, if this is a confusing line to you because of the I, this maybe helps make it clear. And these are just like subtleties of choosing how readable you want your code to be, or when you come back later, you'll get really familiar with this and like what it represents inside of a loop. It just takes some practice. I am not understanding where you set the value of I as students' scores. Yeah, so that's part of the for loop right here. So this style, there's a lot of different styles of for loops. Let me go back real quick to, we're approaching almost the end of the class, so I don't want to go too far over. I know I went pretty far yesterday. So let me go back to session 1. And if you don't have these slides, we can link them to you, Gabriel. Let me go back to, what am I looking for? Iteration. So past operators, functions, control flow, iteration. So iteration talks about loops. And we're basically doing this style of loops right here. So this is a while loop. We're doing a for loop. And so this keyword let I equal the assignment operator. So I'm setting I inside of these parentheses of the for loop, like on the fly. And then this I++ is what increments that I each time the loop runs. So I is 0, and then when it comes back around to run it again, I turns into 1, and then it turns into 2. So it constantly reruns that block of code. But yeah, this is just how this for loop runs. We could also rewrite it to use a while loop, or we could also have used, because it's an array of numbers, we could have just chosen to use this style of a loop instead, where we do let item of array. So we could have chose this as well. So that it will start from the first, yes, yeah, exactly. So for let I equal 0, I'm specifically saying I is 0 because of that indexing thing that we talked about. Let me go back to that screen. Because of indexing, right? I chose 0 because I want to start at 0 in the array. I said let I equal 0 because I want to start on the very first item. Had I said 1, I would skip the first item. So 89 in that test scores would be gone immediately. I would just skip over it, and I would start from, well, I'm using the student names here, but yeah, if you think about it, the same thing here. Let me put these side by side so it makes as clear as possible. So the representation here is like this, right? These are index positions. So I is representing one of these numbers, and it starts at 0, right? So students is equal to that array. So if I say students 0, I would get that item, right? I would get 89. So that's basically where that comes from. It's just index positions, and that's how loops have to work, or at least this style of looping. I need to start from 0 so I can access the first item with I. So I will be 0 on the first iteration, and then it will be 1 on the second, and then it will be 2. So I'm basically changing I out so I can change what we're trying to retrieve out of this array. Hopefully does that make more sense, Gabriel? I thought indexing or .length was for position. No, length will give you like the physical size of the array. So this array size .length right here would give you however many items, 1, 2, 3, 4, 5. So that it would give us back a 5. So this line right here is actually resulting in that. So we start off at 0, and this makes I go up 1 at a time. So it runs, and it says, run this for loop while I is less than 5, because that's what that students.length results in. It puts a 5 there in place of it. Does that make sense? This is just a run condition too. So this is what determines if this turns out to be true, this loop will keep running. But if it hits false, if this statement, this condition, this comparison operator causes a true or a false to come back. So if it hits false, this loop stops. It's done. I get that, but how does the value of 89 come out? Oh yeah, so yeah, I think I did it on this side. So let me carry these numbers over just so I can do this. So let student scores equal this array of student scores, right? So if I say console.log student scores and I put a 0, I say give me the 0 index position of that array, and I run it, it says that's an 89 because computers start 0 base index. When a human counts this, they go 1, right? 1, 2, 3, 4, 5, as they count the items. But a computer starts from 0. It says 0, 1, 2, 3, 4. That's how it sees it. So this is the 0 index. If I say student scores 0, that's going to be 89, because that's how I have to access an item in a collection, in an array. So that's what my let I equals 0 is starting from. And if it's still not making sense, just try to practice with it. It'll in console.log, it'll make sense.
Can you put that code challenge in Slack?
Which just
Yeah, that one, the one you did for the
oh, this one. Okay.
yeah, this high
This whole
score.
thing. Okay, yeah, I can do that. And if you're not sure, actually, here, let me show you all how to do this real quick, because I see folks do this all the time. So in Slack, right, there's actually a button down here. It's like a lightning bolt. If you click this, you can create a text snippet, and if you do this, you can actually it brings this up, and you can title your text snippet. So I can paste my code in here like this. You'll see the result of this on your side. And right here where it says type, you can actually select the language. So I know that this is JavaScript, so I can say Java script. So JavaScript / JSON, we're going to choose that one. And it's actually going to syntax highlight it for us. It's going to apply colors and everything. So it'll be really easy to read. A lot easier to read than storing like a wall of text. So I'll put a title for this called, what challenge is this? High score review, high score challenge. I'll just do that. And then I can apply an additional message on top of it. And then this is the channel you want to send it to. So it's already pre-selected because that's where I clicked the lightning bolt from. I was already selected inside this channel. So I create, when I do this on Slack side, you'll get a compressed, like I can see line numbers and I can expand it now. And I can collapse it. So it's a lot more convenient than posting like a huge wall of text. So a lot of folks don't know how to use Slack like this. And yeah, it's a good thing to know how to do, especially if you need help on code and you want to share your code. This is a lot better of a way to do that.
Thank you.
Yep. All right. Does anybody have any questions? I know I didn't stop very many times for questions, and I tried to answer what was in the chat. So if you have any questions, hit me with them. And we're running over on time. So if you do have to go, feel free to go. I'm pretty much done from this point on. I'm just going to do questions or review anything that anyone has questions on, but I'm pretty much done for arrays and array methods and stuff like that. So fire away if you have any questions. Otherwise, it's, we will be doing, what is next week? Or Monday. Yeah, the next session will be on Monday, same time. And we're doing, we're doing objects. So we're moving from arrays to objects, and then objects are you're not going to get away from objects. They're fun to work with too. Slides. Thank you for the Slack information. I'd also like to link for the slides. Yeah, if you scroll up in Slack also, you should be able to scroll through the history of Slack, and there should be 2 links that I posted a while back, maybe 3 or 4, maybe 4 days ago. You might have to scroll up a ways, but yeah, they're in there if you scroll up enough. The slides link, and I think it might have been the original Zoom link, which has changed. So anyways, yeah, the slides link is in there, but someone put it in the chat for you as well. Does anybody have any questions, or maybe something is still confusing and I can go over something if it's still confusing. Again, I just want to make sure everybody's like comfortable with what I showed so far. And don't worry if you don't like don't worry if you don't get it right away, right? Like this is what happened to me when I was a student a lot. I would watch somebody else do it and they made it look, I understood everything they did, right? Like everything they did made sense to me. But the moment I went to go try it by myself is where I was like, I don't know how to do it. I literally watched this person do it and I understood everything, and now I did it and I have no idea what to do. It's gonna happen. But yeah, totally go practice, because that's gonna reinforce everything you learned. We'll have the slides up and hopefully we'll have the video up. I started the video late, but I did start it before we did the challenge stuff. So I actually missed when we talked about methods, array methods. Anyway.
Chris, one quick question.
Sure.
You're saying methods and functions are interchangeable words?
No, they're not. It's hard to go too far into methods because they do mean something else. But here, let me go. I kind of added a definition right here. Well, I guess my own definition for it. It's basically, you can think about it like it's a function, but methods, you can't call them like a global function, right? Like parse int is a global function. You can just call parse. Here, let me do it real quick. You can call parse. I can literally just say parse int. It's never been defined, but JavaScript knows it exists because it's built into JavaScript. But a method you can't, it's bound to a specific like data type, like a string, right? So I have to have a piece, an instance of a data type. So like a string, right? Like it actually doesn't even, it just, this could be it right here. So I can call like two, what is it, uppercase? I could call two uppercase on that. This is basically a method. So I can't say two uppercase because this is treating it like a function, but this is a method. And it's just like a function. You call it and you interact with it just like a function, but it belongs, this one belongs to a string. I can only ever call this from a string type. I can't do it from a number. It won't work. I can't uppercase a number anyway, so that'd be interesting to see. But yeah, so your data types always matter, right? So if it's a number, it has its own methods. If it's a string, it has its own methods. And methods, you can think about them as if they're functions that belong, they have some kind of parent that they belong to. So in this case, it's a string. Well, for this method, it's a string, but you can literally create your own addition, like you can create your own methods. And someday when you get far enough, you're going to get into like writing classes. It gets into object-oriented programming, and that's where methods are used a lot. So if it's attached to something like this dot syntax, it's a method. So to upper, so let me just put it this way, like this is a method because of this dot syntax, I have chained. This is chaining a method call is what that is. But if I defined my own function, uppercase, and it takes a string, right? This is a function. And if I was to do something clever in here, I'm not going to write out the logic to do uppercase because I have to like loop, and I don't want to. It'll take some time. But let's pretend that did something relative to its name. So uppercase stuff. That's a function. I wouldn't do this, right? Because this is just a function. It exists on its own. It's not attached to a string, but it can take a string. So I would call it. So does that difference make sense? Like this is a function, but this dot syntax up here when you see this, it's usually a method.
That makes sense. Yeah. Thank you.
Yeah. Okay. Sweet. These are good questions because I've never had to like, some of these I've never had to explain, like break down that far, but it's good. It's good to break down things like that. Good practice for me too. All right. Well, if anybody else has any questions, now's your time to shine. Otherwise, I'm going to end this stream and we'll come back on Monday for covering some objects. And yeah, just make sure you go through strings, numbers, and array methods. Like go through the MDN docs and like try to use maybe methods that we didn't talk about and see what they do. Console.log them out, or just try to make sense of the behavior that they do. And even if you don't make sense, it's good practice to just trial and error. Development, a lot of development and learning development is purely trial and error. I can't tell you how many errors in my life of development I've had to go through, like error by error, just failing, and it feels like you're never going to get to the result, but you will. It definitely takes practice. It takes iteration, practice, iterating over and over again. All right, I'm gonna go ahead, and it doesn't seem like anybody's asking any questions, so y'all have a good night. I'm gonna go ahead and stop this, and hopefully we'll have this up tomorrow. I'm gonna work with Tom to try to get this up as soon as possible, so if he's still awake, I'm gonna go bug him. I'll catch you guys later.